Okay, picture this. I walked outside, headset still on, apparently grinning in the dark like an optimistic lunatic. That's how one researcher described the feeling after a recent live stream
Yeah.
and the claim that followed. This is the smartest AI in the world. Now that's a statement that should probably grab your attention.
It's an image that absolutely sticks with you, doesn't it? Really captures the moment. And, what we're diving into today is exactly why that feeling and, yeah, that really bold claim have taken on this whole new profound gravity.
Okay, let's unpack this then. Our deep dive today is all about Grok 4 and its, well, truly unprecedented performance on a new, incredibly tough academic benchmark called Humanity's Last Exam, or HLE.
HLE,
Our mission, to pull apart what HLE actually is, how Grok 4 scored so high, what those scores genuinely mean for the future of AI, and why this breakthrough isn't just technical, but maybe a big psychological one for all of us. We're giving you the shortcut to getting up to speed on this.
And just to give you a sense of the scale right away, Grok 4 hit a peak score of 50.7% on HLE. Now, put that against, say, the median human expert score. That usually hovers around 5%.
5%, wow.
Yeah. So basically, Grok 4 did something that, well, until now, a whole room full of PhDs together just couldn't manage.
That is astounding. Okay, let's start with the exam itself. What exactly is Humanity's Last Exam? I mean, the name alone sounds pretty intense.
Oh, it absolutely is. HLE is not your standard multiple choice test. Not at all. It's this meticulously crafted collection of, get this, 2,500 graduate-level problems.
2,500.
Yeah, spanning over 100 distinct academic fields. Imagine the toughest questions from basically every PhD program on Earth, all rolled into one single exam.
Wow, okay, that's not just broad. That sounds deliberately comprehensive. Who put this beast together, and what were they aiming for?
Well, it was an alliance. Researchers from Stanford, Cambridge, Utah, and also several independent labs. Their stated goal, and this is key, was for HLE to be the final closed-ended academic benchmark.
Final closed-ended. What does that mean exactly?
It means basically, once an AI masters this kind of test, the thinking is that AI research really needs to shift beyond these sorts of academic problems, towards more complex, real-world, interactive challenges.
So it's designed to be brutally difficult then, to really push the absolute limits of what an AI can know and reason about.
Precisely. Every single question is so hard that most individual humans, experts even, score well under 10%.
Under 10%.
Yeah. And there's no partial credit, no internet allowed during the test, no reruns, no second chances. It's a one-shot deal. And, as the researchers themselves put it, that brutality is exactly why it matters, because when a model actually thrives on HLE, we learn something genuinely new about scalable, unified reasoning. It's built to find any gaps.
I can only imagine the range of subjects. Can you give us a sense of the curriculum? Like, what areas are weighted most heavily?
It really does cover a massive range. You've got everything from the most abstract mathematics, which maybe surprisingly makes up 41% of the exam.
41% math.
Yeah. Huge chunk. Then there's cutting-edge biology and medicine. That's about 11%. Computer science and AI is 10%. Humanities and social science, about 9%. Physics, also 9%. Chemistry, 7%, engineering, 4%, and then a miscellaneous category for the rest, another 9%.
Okay.
So the variety isn't just broad. It's designed, like I said, to expose any gaps in a truly unified understanding.
All right, let's get a taste of this brutality.
Yeah.
I want to hear some of these questions that supposedly haunt dreamers.
Yeah.
Give us a feel for just how specialized and difficult these really are.
Okay, prepare yourself. Here's one for mathematics. Now, don't worry about understanding every single term here, but just listen to the kind of complexity. It involves things like natural transformations between functors,
Okay.
defining something called coends, and then applying these really abstract concepts to categories involving the nerve of the decoping of the symmetric group.
Okay, my brain just melted a little bit there. Honestly, for most of us, that's just a string of very advanced words. Can you maybe give us a sense of what kind of mathematical thinking that needs without needing a PhD right now?
Yeah, fair enough. That problem is pushing the absolute limits of abstract algebra and topology. It's not about simple calculation, solving for x. It's about a deep, interconnected understanding of mathematical structures, stuff that even most mathematicians specialize away from because it's so foundational. It tests that really core conceptual reasoning.
Okay, I think I get the spirit of it, if not the details. What about chemistry? Next up.
Right, chemistry. There's a question about a thermal paracyclic cascade. It describes this multi-step chemical conversion, making something called endiandric acid B-methyl ester, and it asks for specific types of reactions, like electrocyclizations and cycloadditions. Again, not just recalling facts, but applying complex mechanisms to a novel situation.
Complex mechanisms, got it.
Yeah.
And maybe something from the humanities. Linguistics, perhaps.
Yep. From Linguistics, one question asks you to mark the closed syllables in a specific Hebrew verse from Psalms. But not just based on modern Hebrew, no, using the ancient Iberian pronunciation tradition.
Wow.
So this isn't just knowing a language, it's deep historical linguistic analysis. You need knowledge of very specific ancient phonetic rules.
Okay, let's take a breath.
Hmm.
These aren't just hard. They are incredibly specialized. They require this deep, interconnected knowledge that, like you said, even human experts would struggle with, probably need reference books for.
Exactly.
And you're telling me Grok 4 just answered these without cracking open a textbook?
Well, that's the really striking part. These are the kinds of puzzles that force veteran professors to hit the books or collaborate. Now, Grok 4 didn't reach for books in the human sense, but yeah, it answered a quarter of the entire test correctly without any external tools.
Later, just raw.
Just raw. And then an astonishing half of the questions with tools enabled.
Half. Okay, so given how insanely challenging these are, the obvious next question is, how did Grok 4 actually do against other top AIs? Let's start with those raw scores, no tools involved.
Okay, in that raw text-only showdown, Grok 4 did lead the pack. It scored 25.4%.
Okay.
Gemini 2.5 Pro was next at 21.6%, and then GPT-4 came in at 21.0%. So even baseline, no tools, Grok 4 was already ahead.
And then when tools were allowed, that's when things really took off, didn't they?
Oh, significantly, yeah. With tools enabled, Grok 4 jumped right up to 38.6%, and its more advanced version, which they call Grok 4 Heavy, that reached 44.4%.
44%. And how did the others compare with tools?
Right. For comparison, Gemini 2.5 Pro with tools scored 26.9%, and GPT-4 with tools got 24.9%. So quite a gap opened up.
You mentioned the tool-enabled scores hitting 44%, but then you said it peaked over 50. Was there a specific moment, maybe during that live stream, when things really clicked and pushed it over the edge?
Yes, that was the really remarkable moment, the headline grabber. During the live stream, when XAI sort of unleashed the full swarm, as they put it, agents, context windows, Python calls, that's when Grok 4 quietly edged past the 50% mark.
Wow.
That was the breakthrough, hitting a level that honestly seemed almost unimaginable before.
So this toolbox factor, it's clearly crucial. How did it help Grok 4 climb from, 38% up beyond 50%? And maybe more importantly, what exactly do we mean by tool use here? Is it cheating?
No, absolutely not cheating. And that's a really critical distinction to make. Think about it this way. Humans use calculators, microscopes, search engines like Google, Stack Overflow, right? We use tools every single day to solve complex problems.
I mean, we'll call that cheating.
Exactly. The key isn't whether you use a tool, but knowing when to use it and why it's the right tool for that specific part of the problem. It's about judgment.
Yeah, Elon Musk weighed in on this, didn't he? He had a pretty clear take on why Grok 4 excels here.
He did. Musk put it pretty plainly. He said, basically, we actually put the tools into training. Grok 4 started thinking from first principles and correcting its own mistakes.
So it's not just blindly using a tool. It's strategically deciding to use one, maybe when it's unsure, and then checking the results. That sounds like a kind of sophisticated internal loop, like self-correction.
It really is. If you look at Grok 4's reasoning logs, you see the sequence. It drafts an answer, then it actively detects its own uncertainty. Little search. It verifies the substeps, and through that process, it basically halves its error rate.
Halves the error rate. Wow.
Yeah, and this loop repeats constantly, especially inside what they call these multi-agent study group shards that power the Grok 4 Heavy version.
Oh, okay, hang on. Context windows, multi-agent shards.
Yeah.
What exactly do those mean for how the AI actually works? Can you paint a picture for us?
Good question. So context windows. Think of that like the AI's working memory. How much information it can hold and actively consider at one time. Bigger window means it can connect more ideas without losing track of earlier details.
Okay, makes sense.
And the multi-agent shards, especially for Grok 4 Heavy, imagine creating multiple independent copies of Grok, Each one tackles the same problem in parallel, reasoning it out privately, like in a little scratch pad.
Yeah.
Then they all come together, they sort of compare notes, debate their findings, maybe argue a bit internally, and then merge their best ideas into one final, refined answer. It's like a super-powered internal study group.
A study group of AIs.
Exactly. And the result is a model that just feels startlingly deliberate. It's not, bluffing its way through these complex problems anymore. It's actively consulting resources, checking its work, its thinking.
Okay, so beyond HLE, which is obviously the big headline grabber, what else can Grok 4 do? I mean, HLE might be the billboard, but I'm guessing it's good at other things too.
Oh, absolutely. Yeah, HLE is definitely the main story right now, but Grok 4's performance across a whole range of other challenging benchmarks really paints a fuller picture. It's definitely not a one-hit wonder.
Okay, give us some of those numbers. Where else is it pushing the boundaries?
Right. So on ARC-AGI v2, which is a test designed to measure more general artificial intelligence, Grok 4 Heavy scored 19.4%. The next best model was way down at 9.2%.
A difference.
Huge difference. Then there's GPQA, that's graduate level physics questions. Grok 4 Heavy hit 92% there versus 74% for the next best.
92% on grad level physics.
Yeah. It got a perfect score, 30 out of 30, on the AMIE 2025. That's the American Invitational Math exam. The next best got 29. And on a live coding benchmark, testing its programming skills, Grok 4 Heavy scored 96% compared to 83% for the runner-up.
So it's pretty clear Grok 4 has a real niche. It dominates. It sounds like it's really built for that deep, complex reasoning.
Yes, absolutely. Right now, Grok 4 basically owns the top spot in these reasoning-heavy benchmarks. Now, it does trail a bit on some tasks that are more vision-heavy, analyzing complex images or videos. But XAI says they expect that gap to close pretty quickly with version 7 of the model, which they say is coming very soon.
And with all these impressive numbers backing it up, those more bombastic statements Elon Musk made during the broadcast, they suddenly have a new kind of weight, don't they? What were some of his big pronouncements?
He definitely had some striking remarks that, now feel less like hype and maybe more like, prediction. He said things like, with respect to academic questions, Grok is better than PhD level in every subject, no exceptions.
No exceptions. Wow.
And I expect Grok to discover new technologies as soon as later this year, and I would be shocked if it has not done so next year.
Discover new tech this year. That's bold.
Extremely bold. And he also declared, we are at the beginning of an immense intelligence explosion. We are in the intelligence big bang right now. Hearing those lines after seeing the HLE numbers, it definitely gives them an unusual, almost unsettling gravity.
That intelligence big bang quote.
Yeah.
It does make you pause. Let's circle back to Grok 4 Heavy for a second and this multi-agent offset you mentioned.
Yeah.
How exactly does that process work? Having multiple Grok instances collaborating, how does that get those much higher scores?
Right, the multi-agent part. Think of it like this. Imagine 10 really bright students all taking the same incredibly hard exam, but independently, in separate rooms.
Yeah.
Once they're done, they all come together in one room, they huddle up, they argue, they debate their different answers, show their work, and then they merge all their best ideas onto a single final answer sheet. That's essentially what Grok 4 Heavy is doing internally.
So it's basically an AI study group, but supercharged and incredibly efficient.
Precisely. Technically, what happens is an orchestrator system forks, or creates, many Grok instances. It lets each one reason privately, maybe in its own scratchpad memory space. Then it requests proofs or justifications from each of them for their answers.
And this costs more compute, obviously.
Oh yeah. It costs about 10 times the compute power of just running a single Grok instance. But, and this is the crucial part, it lifts the accuracy by a similar ratio, roughly tenfold as well. Engineers call this the compute to quality curve. And Grok's curve seems to be particularly steep right now, meaning putting in more compute power yields significantly better results, especially for complex reasoning.
Okay, that brings us nicely to the new HLE leaderboard then.
Okay.
Let's just lay out the new order of things now that Grok 4's full performance is out there. How does the top stack up?
Right, the new pecking order. At the very top, you have Grok 4 Heavy, that's with tools, and the multi-agent system hitting approximately 50.7%.
50.7. Okay.
Then you have the standard Grok 4, just with tools, at 38.6%. After that, it drops off a bit. Gemini 2.5 Pro with tools is at 26.9%, followed by GPT-4o3, also with tools, at 24.9%. And just for reference, the best score achieved by aggregating answers from multiple human experts is around 19%.
19% for humans.
Oh.
Wow. That gap between Grok 4 Heavy at the top and the next competitor, Gemini, it's pretty astonishing, isn't it? I mean, that seems to justify all the
It
buzz.
really does. The gap is significant. Think about it. The difference between first place, Grok 4 Heavy, and second place, Grok 4 Standard, is bigger than the entire gap between second place and fifth place on that list.
Well,
Now, is it possible the nature of HLE particularly suited Grok's strengths? Maybe. Researchers will definitely debate that. But the sheer breadth of the exam, remember, over 100 fields from math to linguistics, suggests it's not just some narrow niche, it's acing. The scoreboard right now shows a pretty clear dominance in this specific, very tough domain.
so why is 50% specifically? Why is that number such a psychological threshold? It feels a bit arbitrary, but clearly it means something more profound in this context.
Yeah, it might seem arbitrary, but it's really not. Passing half of HLE means the model is now answering more of these incredibly advanced research questions correctly than incorrectly.
Ah, okay, the balance tips.
Exactly, the balance tips. And that fundamentally flips the script on how researchers interact with it. Instead of constantly asking, is it going to hallucinate? Is this answer reliable? The question starts to become, okay, this looks promising. Can it actually push this idea forward for me while I focus on verifying the key steps?
Yeah.
The workflow shifts from what often felt like babysitting the AI, constantly correcting it, to something much closer to actual collaboration. It crosses this line, I think, from being maybe an entertaining novelty or a sometimes useful assistant to potentially a genuine, reliable productivity engine for complex tasks.
That is a huge shift in perception. Anyone who's wrestled with getting tech to do exactly what they want, that idea of collaboration instead of babysitting sounds almost revolutionary.
Right.
What are some of the practical wins then? Things emerging right now from this kind of capability, real world stuff, not just theory.
Yeah, we're already seeing them bloom, which is maybe the most exciting part. Like in drug discovery, the RC Institute reported Grok 4 spotting really complex patterns in CRISPR gene editing logs in just minutes.
A minute.
Yeah, a task that would normally take human researchers days or even weeks of painstaking analysis.
Oh.
In finance, you've got traders feeding Grok real-time market data along with Python libraries for analysis and watching it draft surprisingly comprehensive backtesting strategies from a single prompt.
Huh.
In physics visualization, the demo team asked Grok to simulate two colliding black holes, a notoriously difficult problem. And the model generated a waveform that was described as visually plausible without needing massive external GPU render farms, which is usually required.
Just generated the visualization itself.
Based on the physics understanding, yeah. And maybe my favorite example, a solo game developer apparently built a working first-person shooter prototype in just 4 hours.
4 hours.
By letting Grok 4 do a lot of the heavy lifting. Fetching textures, synthesizing level geometry, writing the actual Unity game scripts. It's pretty wild. And notice the pattern. Each of these relies on that combination of deep reasoning plus intelligent tool use. That's why HLE turns out to be such a good proxy for this kind of real-world agency.
Okay, so for us, the humans not named Elon, why does this matter? What's the broader ripple effect of this kind of breakthrough for our lives, for society as a whole?
Well, the ripple effects are potentially huge, really, for everyone.
Yeah.
Think about research velocity first. If scientists can reliably offload things like literature reviews, data analysis, hypothesis generation, and pruning to AI, you could see a massive spike in the speed of discovery across many fields.
Right, accelerating science itself.
Exactly. Then think about education. It will inevitably have to shift more towards open-ended projects, creative problem solving, because honestly, closed book exams don't reveal much about human skill anymore if an AI can just ace them cold.
Good point. The definition of skill changes.
It has to. In software engineering, developers are essentially gaining a pair programmer that doesn't just write code snippets, but can analyze existing code bases, write detailed diffs, suggest complex refactors, maybe even generate entire modules.
That could change programming workflows entirely.
Completely. And maybe most crucially, the big policy debates. They're going to have to move beyond the basic question of, can AI reason? We just saw it can, at a very high level. The urgent question now becomes, how do we effectively align and control increasingly capable AI reasoners? Every one of these shifts really traces back to this moment, this crossing of the 50% threshold on HLE.
This all sounds, well, all's too good to be true in some ways. Let's maybe pump the brakes just a little bit. Are there limitations here we need to keep in mind? Critical perspectives that offer a more nuanced view?
Yes, absolutely. It's important to keep perspective. While HLE is a fantastic stress test for dense academic logical reasoning, it definitely leaves entire cognitive provinces unexplored. Well, it doesn't test for things like, say, improvising a beautiful melody, or sensing a colleague's frustration from their tone of voice, or planning a complex 5-year product roadmap and then adapting it on the fly as market conditions change completely. Those kinds of dynamic, open-ended, real-world intelligences.
Right. So future tests need to be broader.
Exactly. Future evaluations will need to mix these hard science-type riddles with creativity challenges, social simulations, long-term planning tasks, things that unfold over weeks or months in the real world, not just hours on a static test. HLE is a milestone, but it's not the whole picture of intelligence.
And there's still some philosophical debate around the whole tool use aspect itself, right? Some critics might see it as a crutch, arguing it's not really independent intelligence if it has to call Python or search the web.
Yeah, that's definitely been a bit of a philosophical skirmish. You hear the criticism. A model solving HLE only after summoning Python or running a search query is just leaning on a mechanical crutch. It's not pure thought.
So what's the counterargument?
Well, the counterpoint is pretty straightforward, I think. Humans wield notebooks, microscopes, calculators, Google search every single day, right? And we don't typically dismiss their intelligence because of it. What really matters is adaptive judgment, knowing when and how to use the right instrument. You could argue that Grok 4's apparent knack for asking itself, I'm not sure about this step, should I verify it with code, is itself a mark of sophisticated reasoning. It shows a kind of meta-awareness of its own limits and capabilities.
Okay, that makes sense. It's about how it uses the tools. And then there's always the risk with these big benchmarks of benchmark leakage, isn't there? The possibility that some test questions accidentally ended up in the training data. How do we guard against that?
Correct. Benchmark leakage is a legitimate and ongoing concern in the field. Test questions can inadvertently seep into the massive data sets used for training, maybe through public forums, code repositories, research papers, snippets found online.
So how do labs like XAI try to prevent that, to make sure the results are genuine?
Well, the HLE authors specifically say they guard a private, unseen test split. And responsible labs employ rigorous methods, things like carefully tracking the provenance of their training data, actively filtering out known benchmark text, and advocating for continuously refreshed hidden test sets. It requires constant vigilance to keep these evaluations meaningful and ensure they're truly testing novel problem solving, not just memorization.
Okay, so vigilance is key. Looking ahead then, what's next? What are XAI's plans for Grok after this big splash? And what might we expect to see, maybe even in the short term?
Well, XAI is definitely not resting. They're already talking about version 7 of their foundation model, and they've said it's expected within weeks.
Weeks? Oh.
Yeah, really soon. This next version supposedly brings significant advancements, especially in understanding video input and handling even larger amounts of information, those bigger context windows we talked about.
And they're putting serious resources behind this.
Massive resources. If their compute ramps hold, and Musk mentioned figures like needing 200,000 GPUs just for the reinforcement learning phase.
200,000.
Yeah, just an enormous amount of computing power. If that holds, we should probably expect another significant leap on that reasoning evaluation curve very soon. And looking further out, they talk about enabling richer multimodal prompts, combining text, images, video, achieving tighter error bounds for reliability, and eventually giving these models robotic bodies to interact with the physical world.
It sounds like Musk's core philosophy continues to drive things. The ultimate test isn't a paper exam, it's reality.
It really does. He often says things like, reality is the ultimate judge. Does the rocket actually get to orbit? Does the medicine actually work? His point seems to be that future exams for AI will involve steel and atoms, not just PDFs and text files. And yet, as he also put it, humanity just witnessed the last, maybe the greatest, giant paper tests get half solved by silicon. That metaphorical bell, you know?
Yeah.
It really can't be unwrong.
What a moment to be witnessing. Okay, so to bring it all home, let's summarize. What are the key takeaways for everyone listening from this deep dive into Grok 4 and humanity's last exam?
I think there are 3 big ones. First, Grok 4's peak score, especially that 50.7% on HLE, it fundamentally changes the psychological landscape of AI evaluation. It resets expectations.
Right.
Second, tool-augmented reasoning AI using tools intelligently is now undeniably the metric that counts for measuring advanced AI progress. It's shifting from just raw intelligent potential to actual intelligent application and problem solving.
Okay, tool use is key.
And finally, as a consequence of those first 2 points, expect new research, new products, entirely new societal questions and challenges related to AI. They're likely going to bloom much, much faster than most timelines predicted, even just a short while ago. Things are accelerating.
That is a lot to process. And honestly, yeah, those singularity jokes you sometimes see on Reddit, they feel maybe a little less like jokes tonight. As Musk himself said, closing out that live stream, we are really at the most interesting time to be alive in history. What does it mean for you listening right now to be living through what he calls an intelligence big bang? It's definitely a question worth pondering as we close out this deep dive.